Hello everyone, welcome to Joseph Mhlongo's Mathematics and Physical Sciences YouTube channel. And today we'll look at Mpumalanga Province, the Hersivande Mathematics Term 1 test for March 2025. We'll start off with question 1. As you know, that schools are going to be reopening soon. And you have to review the work that was done to prepare yourselves for the June exam. Okay. Question 1 was strictly algebra, whereby you're given m, which is equals to the square root of 9 all over 11 minus x, and the x values that were given are an element of minus 5, 0, 11, and 15. And the first question that is asked here is that for which values of x will m be a rational number? That's A. Right, so we're looking for 1.1.1a. When will it be a rational number? Remember, a rational number is a number that can be turned to a fraction, whereby a is an integer and b is an integer. So we want to make our equation to be an integer. Already, m has a 9 over 11 minus x. So basically, we will have to change our value or denominator here in order to become a integer. So how will this one become an integer? So we're gonna go by trial and error first. For example, the first digit is a minus 5. So do we get an integer when we say 11 minus negative 5? We do get 11 plus 5, which is equals to 16. Therefore, value of m here will be something like a 9 over 16, of which will then give us a 3 over 4. So correct answer here is that for x to be equal to negative 5. Next one says for m to be undefined, which values of x will make m to be undefined? Now, back to our analysis. Number B, for a case to be undefined, or case m or m to be undefined, um, we need the denominator to be 0. How can we get the denominator to be 0? We get the denominator to be 0 if we take the denominator and solve it for x, for example. But here we're given x, so we don't have to solve for x. But in most cases, you would just say 11 minus x equality to 0, then you say 11 is equal to x. But in our case, you don't have to do this whole thing. So you can simply say, what is 11 minus if I substitute? What are the values given? I'm given 5, 0, and 11. So let me try 0 with 0. You don't get a denominator that is 0. So I'm substituting 0. So in this case, you will jump into substituting for 11. And that gives you a 0. And therefore, when x is equals to positive 11, then the equation or m will be undefined. Last one is C. Now at C, we're talking about how would you make this to be non-real? How would you make a number or any number to be non-real? So you get non-real numbers when you get the square root of negative number. I'm just gonna write hash here. So negative numbers. How would you get a negative number? Basically, you would have to find a bigger positive value that is bigger than 11. So this means 11 minus x must be a value of what's coming after 11 is 15. 11 minus 15, which gives us a negative 4. And therefore, m will be a 9 over negative 4, and then that is non-real. Therefore, x should be equal to positive 15. Right. Then they say you must round off the value of m to two decimal places if x equals 0. Now, if x equals 0, this is 1.1.2. We have m being equal to the square root of 9 over 11 minus 0, which if I punch in a calculator, the square root of 9 over 11 minus 0 gives us 0.904. Right. Say this is not the final answer. 90453. Alright, we did a rounding of numbers and the video is posted in our YouTube channel. So we'll have to take these two digits because they said it was round off to two decimals. So it's 0.90. That will be the final answer. Last but not least, well, it's not last, second last, determine without the use of a calculator between which two consecutive integers the square root of 61 lies. Now, I teach this also in a different method of which is cheating the system. So I say in 1.2, what is the value of square root of 61? Then they give square root of 61. They said without using a calculator. But this is a pro easier method. I haven't come across the simplest one. If I do, I will try and adopt it. So you get 7,810. And I asked the learners, where would you put this in a number line? Okay, 7.8 would be here, and possibly the integer 8 would be here. And after some units, you'd have 7 here. Already you have the answers, but this is how we do it in a stepwise format. So I start by saying, all right, you know that for 7.8 to be there, there was a 7. So I just start by saying 7 squared, because 7 squared is a what? Is a 49. 7 squared comes before 61. And then after it comes 8 squared. Then we apply the square root of this 49, apply the square root of this 61, and the square root of this 64. Right. The value of their square roots tells us that this one is less than that one and that one. Why? Because here you're going to get 7, which is less than square root of 61 and less than square root of 8. So therefore, this will be between the integers 7 and 8. The last question in algebra says that you must express 0.348, a long line at 48, in the form a over b, where a is an integer. Basically, they want you to make it a rational number. And here's how we started in 1.3. Now 1.3, we're given 0.348 with this dash. We let our value of x be equal to that 0.348, 48, 48, 48 up to the last one. And that will be our first equation. And then we'll multiply on both sides by 10. So it means on the left hand side we'll say 10 times x, we get 10x. And then we say 10 times 0.34848484848. Then we get these three moving towards the left to give us 48484848. And that gives us equation 2. We can do the subtraction only if these digits and these are the same, the digits after the comma. So we have to continue by multiplying with tens, hundreds, and thousands, and maybe 10,000 until those two are the same. Right, so now we're going to multiply uh, equation 1 with 100. So when we multiply equation 1 with 100, we get 100x, which is equals to now 34,848484848. Continuing to make an equation 3. Still, this is not the same as any of equation 1 and 2. So we go to the possibly last one to multiply with 1,000. Now, the 1,000 we get 348,484,848. Now, the trick here is to look at this digit. It is the same as this digit, and then you can say, oh, forgot to label here. Equation 4 will be subtracting equation 2, the one that had the same digits, because we don't want any remainders. We want to turn this into a rational number. So this means that 1,000x minus 10x will be equals to 348, 48 dot dot minus a 3, 48 dot dot dot. And then here we get 990x, which is equals to 345. Then we can divide on both sides by 990. From here we can then do a calculation by our calculators. Then we get 23, an integer, all over 66, also an integer. And that's it for question 1. I think I should continue through with question 2. In question 2 was about factorization. Factorize the expression fully. 3k, open bracket, m squared plus 2 minus 4m cubed minus 8m. Right. Let's get to it. We are given in 2.1 to 3k, open bracket, squared plus 2 minus 4m cubed minus 8m. Right. This has already been factorized. These are two factors already, so which means we have to focus on this one and making this one look like this one. Okay. May sound a bit confusing, but you get the hang of it. So now 3k m squared plus 2. What is a common factor here and here? I see a negative 4 in both of them and an m. So if I remove that, I'm left with m squared plus a 2. Then lastly, we take one of these factors first. It's an m squared plus 2. Then we make these two their own factor. So it's 3k minus 4. When you go to the second question, it says if a squared plus b squared is equal to an 8ab, show that a plus b squared is equal to 10b in terms of a and b. Now this question would uh, appear maybe in a grade 11 setting, but they put it for grade 10, which means you guys are capable of doing it. Right, 2.2. We're given that a squared plus b squared is equals to 8ab. It did not say anything further about that. And also that a plus b squared is equals to a 10ab. Right. Now, you want to show that this is equals to 10ab. When you have to show, you start by focusing on the left hand side. The left hand side has a plus b and a plus b. All right. What do we do with that information? You expand it to a squared plus ab plus ab plus b squared. Then you now have a squared plus 2ab plus b squared. Now you go back to your tools. How am I going to get to 10ab? Your tools say that where there is a squared and there is b squared, those two are the same as 8ab, which means now you must focus on making a squared and b squared together, plus 2ab. Now a squared and b squared, they have been said in the previously or above that they're equal to 8ab. So since this is equal to 8ab, you can somehow write, sorry about that, 8ab plus 2ab, which will be equal to 10ab. Right, next question. Next question is 2.3.1, simplify. I love this one. Simplify x plus 2, open bracket, 3x squared minus 7x minus 1, okay, for 3 marks. 2 point, it's 2 point what? It's 2.3.1. 2.3.1. So it's 2.3.1. We're having a 3k multiply. No, we did that one. It's not 3k. Sorry about that. Maybe I should bring the questions closer from the screen or on the side. But anyway, we are having what is this? We have an x plus 2, open bracket, so it's binomial to trinomial, minus 7x minus 1. So the first thing here to do is take one of these and write it next to this one where they are multiplying. So x multiplied by 3x squared minus 7x minus 1. And then plus 2, 3x squared minus 7x minus 1. Now we can apply distributive law. Right, this gives us a 3x cubed. This gives us a negative 7x squared. This gives us a negative x. Same, you get plus 6x squared minus 14x and minus 2. Sorry about that, it's a minus 2. Now you group like terms. There is no like term for the equation, the term with the third degree, but you have negative 7x squared with a positive 6x squared, and it's minus x, it's minus 14x, which is equals to, oh, there's no equal to, because this is an expression. Alright, this then becomes 3x cubed minus x squared minus x minus 14 equals, why am I putting equal to? I'm so used to equations. Right, think it then, oh no, I made a slight mistake. The negative, sorry about that. Let us check it through here. What happened? We had 6x squared minus 14 minus 2, and then when we were grouping now, when we were now grouping, see what happened. Sorry about the glitches. Right. When we're grouping now, we did not include this subtraction in the minus 2. So this becomes a 3x cube minus x squared minus 15x minus 2, and you get your full marks. Right, next question is on the exponents, which is 5 to the power of 2x plus 1 multiplied by 3 to the power of 2x minus 1 all over 15 to the power of 2x. Right, that will be a 2 comma 3 comma 2, whereby I said we have a 5 raised to the power of 2x plus 1 multiplied by 3 raised to the power of 2x minus 1 all over a 15 to the power of 2x. Okay, this one you must be vigilant. What do you do first? To do first, change any number that is not in its prime to a prime. For example, 15 is not in its prime, so 5 to the power of 2x plus 1 multiplied by 3 to the power of 2x minus 1 all over 15 can be written as 5 times 3 raised to the power of 2x. Right. And then you can do the expansion as per the reverse of a law. Right, this becomes 5 to the power of 2x multiplied by 5 to the power of 1 multiplied by 3 to the power of 2x multiplied by 3 to the power of negative 1 all over. Now I'll have to apply what I call law number 3 or 4. I forgot. That's 5 to the power of 2x multiplied by 3 to the power of 2x. Okay. Now we already can isolate the ones that look the same from the top and the bottom. So it's a 5 to the power of 2x multiplied, because these are multiplication, you can just swap or interchange. I don't know what correct term should be used, but 3 to the power of 2x multiplied by 5 times 3 to the power of negative 1 all over. It's a 5 to the power of 2x multiplied by 3 to the power of 2x. And then I can divide these ones in order to have a 5 multiplied by 3 to the power of negative 1, which is the same as 5 times 3 to the power of 1 over 3. And this becomes 5 over 3. Question 2, still not done. On to the second last one, which is an x squared plus x plus 1 all over x cubed minus 1 minus x squared minus 2x plus 1 all over x minus 1 cubed. Alright, there's quite a lot that must be done there. 2 comma 3 comma 3. We have x squared plus x plus 1 all over x cubed minus 1 minus x squared minus 2x plus 1 all over x minus 1 cubed. Alright, we'll start off our equal sign and look at the numerator. This numerator doesn't look like it can be factorized, so let's leave it plus 1 because of the plus 1. And then if we factorize the difference of two squares, difference of two squares says you take the first term and the last term, meaning here and here, first term and last term. So that's x minus 1. Then you take the first term squared, so it's x squared. Then you add it with the first term multiplied by the second term or last term. So this becomes a positive x plus a 1 minus here. This is factorizable. So we can just open two bracket, put x and x, and since the sign here is positive, we'll put negative and negative. And to get that last number or last digit, positive 1. We must say we must say negative 1 times a negative 1 all over. We can also expand this one to x minus 1, x minus 1, 3 of them, x minus 1. And therefore, we can clearly see that there's a lot of division that's going to happen. This is going to divide this, and these are going to divide each other. All right. So when we proceed, this is equal to, I'm going to change this color, it becomes a 1 all over x minus 1 minus a 1 all over x minus 1, which is equals to 0. Now let's try and see if we can do question 3 quickly. Otherwise this video is going to be too long. Okay, question 3. I need to attach the question 3. Very short. Okay, question 3. Everything seems to be looking nice. We have 3.1, which says solve for x squared minus 3x minus 10 equals to 0. Alright, now we've got x squared. We already see that the 0 law can be applied here. So this is x, this is plus 2, then minus a 5. So now we have to simplify to say x plus 2 is equal to 0 is giving us x is equal to minus 2. Oh, x minus 5 equals to 0. Change it to x is equals to, well, 0 minus 5 is just a minus 5. 0 minus 5, 0 plus a 5, because the 5 is going to go to that side. So it just becomes simply 5. Okay, 3.1 and then 3.2. They've given us a half raised to the power of 3x plus 1 equals 32. Most learners feared this question. 5.2, we've got half raised to the power of 3x plus 1 is equals to 32. And then we need to change also here into prime or exponential. So 1 over 2 as exponential is 2 to the power of negative 1. 3x plus 1 equals to 2 to the power of 5. Right, now we have to apply the law number 3. So this becomes 2 to the power of negative 3x minus 1, which is equals to 2 to the power of 5. And now that the bases are the same, check out more videos of us that explain the importance of a base. So we have, now that the bases are the same, it means the exponents are equal. So it's equals to 5. And this becomes negative 3x is equal to 5 plus 1. Now negative 3x is equals to your 6. You divide by negative 3 on both sides. Then x is equals to minus, when the pot there, it's a minus 2. Alright, last but not least, in question 3, 2t is equals to 2x plus 5. Solve for x. Basically here they're saying rearrange the equation such that it belongs to x. Okay, so you can see here it's 3.3 with 2t is equals to 2x plus 5. Now 2t minus 5 will be equal to 2x. And if we divide everywhere by 2, we get that x is equals to t squared over 2. Well, not, why am I saying t squared? Sorry about that. It's a 2t over 2, which becomes now a t minus 5 over 2. Okay. Then in question 4, we have question 4. which is a bit lengthy also. Question 4. Solve simultaneously for x and y. Okay, in this one, to make things short, I'm just going to use x in this case. Then you can on your own do the one with y. Right. So we're given this equation here in 4.1. It's x plus 2y equals to 4, and then 3x plus y equals to 7. Then we label this one as equation 1 and this one as equation 2. We need to define either one of these equations by x and y. So if we say the first equation, x plus 2y equals to 4, makes x the subject of the formula, this will become 4 minus 2y, right? And then we label it as equation 3. Now we can say, since there's an equation 3, substitute equation 3 in equation 2, right? Equation 2 is a 3x plus y is equals to a 7. Now, this is 3 times 4 minus 2y plus y equals to a 7. Then we simplify to get our y value. 3 times 4 is a 12. 3 times negative 2 is a negative 6y plus a y equals to a 7. Now this is 12 minus 5y equals to 7. Negative 5y equals to 7 minus 12. Now we are going to get negative 5y equals to negative 5. We divide on both sides by negative 5. We get y is equals to positive 1. Now that we know the value of y is equals to 1, let's get the value of x from x is equals to a 4 minus 2y. So this is 4 minus 2 times 1, which is equals to 4 minus 2, then it's a positive 2. You can start by changing equation 2, make y the substitute formula, and you get the correct or the same answer. Right, let's go back to our question. Given 0 less than 1 minus x over 3 less than or equal to 3, solve the given inequality, that's 4 to 1, and then illustrate your answer graphically, that's 4 to 2. And determine the sum of integers satisfying 0 less than 1 minus x over 3 less than 3. Okay, now we are given here in 4.2.1 a 0 less than 1 minus x over 3 less than or equal to a 3. To remove, or before removing, we want to simplify this one, or what is it said? Solve it. We want to solve it. So we have to be remaining with x only in the middle of the inequality. So we have to remove everything that's next to underneath x. First thing that's underneath x is the 1. To remove a positive 1, just say minus 1 here throughout. 1 minus 1 minus x over 3 less than or equal to 3 minus 1. Then it's minus 1 less than negative x over 3 less than or equal to a positive 2. Now, to get rid of that negative and that divide by 3, we have to do the opposite or the inverse, whereby we multiply throughout by negative 3. What happens when you do that? So you say negative 3 times negative 1, you get a positive 3. And now, if you multiply by a negative, the sign changes to greater than. And then in here, you're going to be having an x, because that's negative 3 times negative 1 over 3. Right. And that becomes greater than or equal to 2 times negative 3 is a minus 6. Okay. So we have to write this one properly to say it's a minus 6 less than or equal to x less than 3. And that's the inequality they wanted. 4.2.2, they said we must illustrate it graphically. Um, illustrate graphically 4.2.2. So we start by the digit on the left and the digit on the right. Then we check circle, circle, all the values of x, including 6, but excluding 3, are in this number line. And 4.2.3, they are saying, what are they saying? Determine the sum of the integers satisfying that inequality. Now, this sum of integers are satisfying that inequality are found between here, the two. So, what are the integers that you find? So this will be the sum of, since -6 is included, we include it here also. -5, -4, -3, -2, -1. We don't put in 0. Then we add 1, we add 2. We can't go to 3 already. So if I now punch my calculator to say -6, -5, -4, -3, -2, -1, +1, +2, we're going to get a -18. That is the final answer. All right, last question, question 4 says tickets for a school concert are sold at 6 Rand for children and 10 Rand for adults. If altogether 150 children and adults attend the concert and they pay 1,100 entrance fee, determine how many children attend the concert. Right, 4.3. We have to make new. So in 4.3, new equations. Let's say the number of children is x. Number of children is equal to x. Then the number of adults will be equal to 150 minus x. Now, they said 6 Rand for children. So it means 6 times the x. But they said, and why am I saying 150 minus 6? Because they said adults and children are 150. So this will be 10 multiplied by 150 minus x equals to 1,100. So now we have to solve for x. This is 6x plus 1,500 minus 10x is equals to 1,100. All right. Now we can group here and say 6x minus 10x plus 1,500 is equals to 1,100. And you get here minus 4x plus 1,500 equals to 1,100. All right. So we can take the -4 to the right hand side and the 1,100 to the left hand side so that we get 1,500 minus 1,100 is equals to a 4x. And then we can divide on both sides by a 4 because this becomes a 400 all over 4 is equals to the x. So x is equals to 100. And therefore, number of children attending is 100. So it means the adults attending are 150 minus 100, which is 50 adults versus 100 children. Then we get to our last question, which is question 5. And question 5 is trigonometry. That was just the basics because in term 1 we're just doing the basics. And it went this way. Given a triangle ABC below, where AD is perpendicular to BC, the length of AC is 5 centimeters, the length of AD is 2 centimeters, and the angle found in ABD, sorry, is angle theta. Now complete the table to define cos of theta according to this triangle. So in 5.1.1, to define cos of theta from SOHCAHTOA, it's just adjacent over hypotenuse. But where is theta? Theta is here. I'll redraw it so that I don't scroll back and forth. Theta is here, and this is B, this is A, and this is D. So we can define, as you see the diagram here, we can define, and also this is a 2. We can define the adjacent side, since theta is facing our left and we're looking at to the right. We can divide the adjacent to be BD all over AB, of which is the same as 2 over AB. 5.1.2, we're looking for cosec of C. Now we go back to our diagram. C is the angle, so which means we must focus on ADC in order to make our conclusions correctly. Now this is the same as 1 over sin, because we look at variable 1, 2, 3, so it's sin of C. Now this is 1 over the opposite over the hypotenuse. Now what is opposite in this, where the angle here is C and this is A? We have 5 here, and we have 2 here, and then we have D here, and a right angle triangle. 1 over the opposite side when the angle is C is 2, or AD. Let's start by AD. AD over AC. Now this is a reciprocal, so we'll have to flip it so that we get AC over AD. We have the values for both of them. So AC is a 5 over a 2. Now 5.1.3 says cos of 90 minus theta. Where do you find cos of 90 minus theta? Let's look at the diagram again. Which means now we're focusing on the right angle triangle ABD. We're focusing on ABD. We have to redraw it to make things simpler for us. ABD. This is theta. Now, when they say 90 minus theta, this is the angle here. 90 minus theta. And then the side here is B, and this one is D, and this one is the side there is B, and then this one it's not B, it's A here, it's B. So which means our angle, we're looking at it from the top, because 90, this is basically cos of A. Alright, we first define it as per trig ratio, adjacent over hypotenuse, and then the adjacent side. When you're looking at 90 minus theta, or from the top, your adjacent side is AD. So this is AD over AB. The side that you have its length here is AD. So this is 2 over AB. Right. Let's check 5.2.1. It said write down the trigonometric functions for DC over 2, and 5.22 says 2 over 5. Now you have to look thoroughly at the diagrams. Okay. DC and 2, how are they linked? DC and 2. So it's 5.2.1 DC over 2, 5.2.1. If we can check here, let's redraw this diagram. A, C, and D here. And we have 2 here, and this is DC. So it means for you to have DC on top, you must be looking from above here, which means the angle that you're looking at is angle A. Basically, it's either tan, cos, or sine of A. Now we want to find out, when you're looking from A, what is the side DC called? The side DC there, it's what? It's your opposite over, now adjacent. Opposite over adjacent is given by tan, and the angle there will be A. Tan of A now would be DC over 2. Therefore, that is the answer they're looking for. 5.2.2, last question. It's a 2 over 5. 2 over 5. How would you get a 2 over 5? Well, in our diagram given here, 2 over 5, we can choose the right angle triangle ADC and redraw it. Let's choose ADC. ADC, right angle triangle, with a 2 and a 5 here on AC. Now, when we say 2 over 5, 2 is the opposite side over the hypotenuse side. Now, this is given by sine of this angle that will be here to see this one as opposite. So sine C is just the 2 over 5 because it's given by what? AD over AC. Right. Thank you for watching. Please stay tuned for more of these March tests that were written in Mpumalanga Hersband region. I think I'll also have more videos coming soon, but stay tuned and like and subscribe and share. Thank you.